This is set up for Bosch alternator regulator testing. This is the regulator that I took out of my failed alternator, and this is a new one. This is a replacement. So first I'm going to test the replacement and see what I'm going to get, and then I connect the failed one, and also I try to compare the two results. So what I've got here is a power supply that allows me to change the voltage. Here I measure the so-called field voltage, so voltage between two brushes that are attached to the rotor winding. Also to these brushes there is LED that allows me to see whether there is any current being driven through this voltage regulator into the brushes to activate the winding. And then we have positive that is connected to the main output of the regulator, and then also the pin that provides voltage after we switch on the ignition. And then there is a negative ground power supply from the voltage from the power supply. So what I'm going to do, I'm going to increase the voltage, observe what's going to happen to the LED, observe what's the voltage here across the brushes, and in a correctly working voltage regulator I should see no power going into the brushes. Then within the certain voltage range there should be actually voltage available here, and then after increasing the voltage too far, the regulator should switch off the activation to the rotor winding, so there should be no power here. So let's do it right now. I'm going to activate the voltage. There's no voltage here, and then we're going to increase it. 2 volts, 3 volts, 4 volts, 5 volts, 6 volts, and at 6 volts we can see there is activation of the power going into the rotor winding. 7 volts, 8 volts, 9 volts. That's probably about maximum. We're approaching maximum. It's 5 volts right now going into the rotor winding. 5.4 at 13. That's where I would expect to be the maximum efficiency of the power regulator. I'm going to increase it further. Oh, now it's 6, and here it starts to drop. So at 15 we had 6 volts, and that's the maximum. At 16 volts it is 2.6 volts only going into the winding, and then we should see decreasing voltage. It's still 2.9, 19 volts, 20 volts, and 21 volts it basically switches off. So there's switch off, as you can see. It's not switching off completely, but there is definitely a difference between 15 and 16 volts. So that's a new voltage regulator. Now I'm going to put my old one that I thought failed. I'm going to do exactly the same test. So I need to change the connections here. So this is connected now, and we're going to do exactly the same test. So we go down to 0 and we increase the volt. 4 volts, 5 volts, 6 volts, 7 volts, 8 volts. Something started to happen. We have 1 volt here across the brushes, and here at 9 volts it is switching on. Then 10 volts, 11 volts, 12 volts, 13 volts, 14 volts, and at 15 volts it switches off. But if we compare the voltage between the new one and this one, the voltage to the going to the winding is much less. So the 6 volts maximum here, whereas here we have 4 at best. And it's not stable. At the 14 volts, where this is where the car should maintain this the voltage. It's sort of like fluctuating a little bit, and here at 15 volts it rapidly drops off. Right? So the regulator switches off. Then again it activates a little bit. Here is 0.8, here is 1. At 8 it goes down to 1. The voltage here across the brushes is much less than in the new voltage regulator, so I think there is a fault here, possibly in this old voltage regulator. So possibly it was failing, and that's why I got the charging wasn't good enough for the battery to maintain its voltage. So essentially that's how you test the voltage regulator, and that's how you compare the new one with the old one, and the values. So up to 6 volts here across the brushes, that's what we should get when we connect the voltage across the battery terminal and terminal, the switching terminal from the ignition and the negative pole. So that's how we test voltage regulator. To understand my test of the voltage regulator, we need to understand how it is connected to the alternator and what really happens, what kind of electronic circuit is inside that controls voltage in the regulator. I think we start with all the electronic components of the alternator. So obviously the alternator is connected to the battery. The positive is connected directly to the positive pole of the battery, and then the alternator casing is a ground connected to the body, to the engine, and engine is connected to the car body, and the same negative pole of the battery is connected to the body, and that completes the circuit. Now inside the alternator, or to be very specific, at the end of the alternator, there are 3 components. There is a rectifier, which consists of 6 diodes, and that's connected to the stator. Here is a stator, so that's the windings, the copper windings that are on the outside of the rotor that doesn't turn, and they are connected to the 6 diodes. That's how it looks like. It sits at the end of the alternator, and here you can see the 6 diodes and 2 metal plates that form a negative and a positive plate. And we can test these diodes separately and check whether they are actually working, whether there is proper conduction only in one direction, whether there is any short circuits here between these two plates. So that's the rectifier. And then this rectified current is being regulated. The voltage, the output voltage, is being regulated by the voltage regulator, and the way it is done is the voltage regulator senses here the output voltage from the bridge rectifier and then changes the voltage, or the current to be precise, current flowing through the winding of the rotor, winding that is spinning inside of the alternator. So if we go back to the first image, here we can see the spinning rotor with one winding there, and the voltage through this winding here through the spinning component is being changed by the voltage regulator. So voltage regulator is responsible for excitation current that is in the rotor. So essentially, voltage regulator senses the current on the input, and on the output it creates a voltage and the current that goes through the rotor. So that's essentially how it's working. This is the voltage regulator in a Bosch alternator. That's how it looks like in MINI, and you can see all the terminals here. So essentially, there are three wires coming out of the voltage regulator, and at the same time of the alternator to the car. Here is a plug with two quite thin wires. One is providing a voltage after we switch the ignition, and that's the L. Traditionally it was the indicator lamp on the dashboard connected to this, but right now this is provided probably through the ECU. And here is the sensing pin that goes directly to ECU, and there is some information being sent by the alternator to the ECU, the car computer. Here is the main output of the alternator, and at the same time these two pins sense the voltage being produced by the alternator windings. Here are the two brushes, so it's positive, so the upper one is connected with this main output of the alternator, and then there is a negative field brush underneath this, and here we have a negative pole for the whole electronics inside the alternator. So this is connected basically to body or to negative pole of the negative side of the voltage of the car electrical system. Bosch also provides an additional output that is not used, as far as I'm aware, by the MINI electronics. So what is really happening in the windings? Here is again the bridge rectifier, the 6 diodes, right, connected to the positive, and then goes to the battery. This is the coming from ignition into this L, so that's connected to the B plus of the voltage regulator. This is connected to this pin L in the plug that comes from the into the alternator, and then it's connected to the dashboard. Traditionally, it was connected to the dashboard. Right now, it is realized by the electronic system in the car ECU, and then it activates after we switch the ignition on. It activates the current going through the rotor. So that's the windings of the rotor, and that's 3 windings of the stator. And after we switch the ignition, the coil in the rotor is being activated, and when we start to turn the car starter, it starts to produce current, and then obviously when the engine starts, the current, the rotor is being fed by the alternator current without draining any current from the battery. And that's essentially how it works. So where is how the regulator works? The regulator, as we said, senses the current, or senses the voltage. So the regulator senses the voltage produced by the alternator. This is the rotor winding. This is the so-called field, and it's connected to the high power transistor. So this transistor switching on and off controls the current going through this coil. Traditionally, there was another transistor that was sensing the voltage and turning this transistor on and off. So this was responsible for providing the current through the coil in the rotor winding. This transistor is responsible for sensing the voltage and turning this on and off. How this sensing was happening traditionally, there was a resistor divider dropping the voltage, and then there was a Zener diode here, and when the voltage was below the threshold, so the aim is obviously to have an output voltage of 3.8 to 4.8 volts roughly from the alternator. It should be around 14.2, 14.4 volts on average. So this voltage divider and this Zener diode was adjusted in that way. Was the values were such that if the voltage went above this threshold of 14.8 volts, this transistor would be activated, would pull the base of this transistor controlling the coil to the ground, and this will switch off. So there will be no current flowing through the rotor, and there will be no voltage produced by the alternator. This would cause a drop in the output voltage. So again, this transistor would switch off because it would sense that the voltage dropped below the threshold. The base would go again up to the would be sort of like activated by this resistor pulling the base up to the positive voltage here. The current starts to flow through the base, and then obviously collector would provide the flow into the emitter and through the coil. So that's essentially how it works. So the essential components was this voltage divider and Zener diode to sense the current and switch on this transistor when the voltage was too high, and this transistor on would switch this transistor off. In the Bosch current arrangements of the Bosch alternators, and that's possibly what's inside the voltage regulator in the Mini. It's all sealed, so it's very difficult to find what is inside. But we can only suspect there is the voltage sensing right now is done by the monolithic integrated circuit, integrated chip. So basically there is no sensing transistor. There is some voltage reference, and the sensing is far more accurate. It is resistant to temperature changes. It is able to reject some noise. It's much more stable. But there is still this transistor that is responsible for the field current. So we can see that actually the whole layout is very similar to this two transistor setup that was traditionally used. So here we can see that the current is going from the positive, that goes from the alternator or the battery, through the rotor windings, and then this transistor that is controlled this time by the IC is allowing the current to go through, or is switching off the rotor current. And that's how the Bosch alternator or the voltage regulator works. Here, these are the components of the voltage regulator. There's obviously protection diode for the winding inside, and that's two components, and that's possibly why we have two big radiators at the back of the voltage regulator. I suspect one is for this IC, and the other is for the power transistor that switches off and on the rotor winding. So that's essentially what it does. My testing setup was connected that way, that the L pin was connected to the battery positive pin here, and that was the positive voltage to the power supply, to the lab power supply. The negative pin here, B minus, was connected to the negative pole of the power supply, and then two brushes were connected to this LED setup and my multimeter that was showing me when the voltage regulator activates or deactivates the current flowing through the supply to the brushes, and what was the voltage actually. So that was my setup for the testing, and this is essentially how the Bosch voltage regulator in MINI R50 works, and how you can test it.